Alright, then we're doing the second page here, and now I'm doing the slope of a horizontal line. Guys, there's two different ways of doing this. One is just memorizing a quick little method, which reminds you if I have a horizontal line, that means all I ever have to know is the y-intercept, which is always your y-coordinate, and that just is y is equal to 12, and you're done. Or you can use what you know about a horizontal line. I know a horizontal line is flat, so its slope is 0. And then you could still use point-slope form. Basically, use what you know. Like if you know the shortcut method, use it. If not, you have to plug and chug it into the point-slope form. So y minus, here's my x1, y1. Y minus 12 equals 0 times the quantity x minus a negative 3. Now here's the cool thing. We have 0 times this. 0 times anything is 0. So you can leave it as y minus 12 is equal to 0. Or could I just go ahead and move it over? Yeah. Y equals 12. I'd even probably take this form, as long as I know initially that's what you were working with. Alright, now here it is, the hardest question of the whole little subunit we're doing on writing equations of lines. You have to write the equation of the perpendicular bisector of a line segment whose endpoints are 5, -2, and 7, 4. So it looks something like this. So here would be 5, -2, and over here we have 7, -4, and I want the perpendicular bisector of that. Remember, if it's a perpendicular, it forms a right angle, and if it's a bisector, it divides into two congruent segments, and it has to go through the midpoint. Now, we need to, for an equation of a line, have a point and a slope. So the neat thing is, I don't have a point on that line, but I can find it. So first, find the midpoint of the line segment, because if it's the midpoint in the line segment, I know it's on the perpendicular bisector. Midpoint, remember, is the average of the x's and the average of the y's. So to do that, I go 5 plus 7 over 2, and then I get -2 plus -4 over 2. So then I get 12 over 2, and I get -6 over 2. So that's 6, -3. So that's my point. Yay! But now I need to figure out slope. Well, the thing is, I need 2 points on a line to find slope. Since I don't have 2 points, I'm going to have to use another piece of information. That's the perpendicular part. I can find the slope of the side of the line segment and then use its opposite reciprocal. So find m of the segment. So the slope of the segment. So the slope again is y2 minus y1 over x2 minus x1, change in y. So I got a -4 minus a -2 over 7 minus 5. So that gives me a -2 over 2, which is a -1. But the slope that's perpendicular to that is the opposite reciprocal, which is a +1. So there's my slope, here's my point. I have to write the equation of the line. Point slope, because that's what I have. Y minus y1 equals m times the quantity x minus x1. Y minus y1, that's a -3. Our slope is 1 times the quantity x minus 6. So that's y plus 3 equals 1 times the quantity x minus 6. Great job. Now we have two other examples, just real quick ones here. I want to write an equation of a line that goes through -2, 7. So I have a point, and it's parallel to the line 3x minus 4y is equal to 10. And then I want to write it in standard form. Right now, I could care less about standard form. I want to make sure you can write the equation of a line, but I don't have a slope. But I know it's parallel to this line in standard form. Well, and remember, standard form is ax plus by is equal to c. Well, I'm going to show you a shortcut way of finding the slope. Your slope is a -a over b. So all I ever have to do to find the slope of a line in standard form is either you change it to slope-intercept form or use this formula, which is going to be a -3 over a -4, which is a +3/4. Well, my line is parallel to it, so it has exactly the same slope. So now I have my point and my slope, and I just plug and chug it in. Here would be your x1, y1, right, friends? So we get y minus 7 equals 3/4 times the quantity x plus 2. because if I'm subtracting a negative 2, it makes it positive 2. It's the first time I've ever kind of skipped on that step and not showing you the middle. If you need to see it, remember, you're working with it. It's going to be here at 3/4, and that's going to be x minus a negative 2. So don't forget that's in there. All right, last but not least example here. We want to write an equation of a line that passes through 2 points. When it passes through 2 points, what's the piece of information we're missing? Our slope. So we're going to use slope, point slope form, but I have to find the slope first. So I go over here and I go equals our y2 minus y1 over x2 minus x1. I'm going to be going this direction. 4 minus 12 over a negative 2 minus 5. That's a negative 8 over a negative 7. So that's a positive 8/7. Now pick either point. A lot of people are picking 5, 12. And so I'm all right with that. x1, y1. So I put it in point slope form. I could choose negative 2, 4 if I want. We just plug it in. Y minus 12 equals 8/7 times the quantity, x minus 5. So that's point slope form. But now I need to change it to slope-intercept form. Well, to do that, you must distribute your 8/7. So I get 8/7 x. If you're not sure what 8/7 times a negative 5 is, your calculator is okay place to check it, but leave it as a fraction. Otherwise, you get really bad decimals. So it'd be 40/7. I'm going to add 12 to both sides. The problem is I don't have a common denominator. Well, what's the common denominator for 12? It's going to be 7. And so you remember, if you do this, you change it by multiplying by 7 to both. So that's a positive 84/7. So a negative 40 plus a positive 84/7 is going to be a positive 44/7. Now, if you need help with this, I can show you how to do that on your calculator and still keep it in fraction form.